Ladies and gentlemen, hello and welcome, coming to you not quite live from One Take Studios, where, get this, today we get to talk about standard normal distribution. Notice the use of the word standard. We have previously talked about normal distributions. That was the whole, if you drop a pile of dry sand, it makes this lovely mound-shaped appearance. So a normal distribution has the mound shape, it has the asymptote, it has the highest point over the mean, and standard deviations, all that kind of fun stuff, all right? So what does it mean to have a standard normal distribution? And better question, why is my print fuzzy? There we go. A standard normal distribution. Well, okay, so the goal here is to actually standardize the distribution, which right now tells us absolutely nothing. But once upon a time, in a land far, far away, there were no calculators. And before that, there were also no computers or anything else like that. So in order to actually figure out what we were talking about for values, they had to standardize everything so they could pull all the data they needed off of one single chart. Now, despite the fact that that sounds archaic, it actually has yielded some kind of interesting things that are worth talking about in our current day and age. And so to do this, to achieve this purpose, the goal then is to determine the number of standard deviations between an original data value and the mean. All right, and this is what we mean by standardizing. So if you see the word standard here, it does refer to something specific in regard to the normal distribution. So, notice original data value x, mean mu. All right, so we've seen those things before. Original data value, sometimes called the raw value, the raw score, something along those lines. Trying to figure out how many standard deviations are between these two. Well, before I just throw a formula at you, I think we can probably figure this out. So let us say, for the fun of it, there we go, that there's this data set out there that exists. I don't know exactly what's in the data set, but I do know that it's got a mean of 20, and that it has a standard deviation of 3. And I have this number 26. It's an original data value. It's one of my raw scores. And I'm looking for the comparison between 26 and the mean. Specifically, how many standard deviations away is 26 from 20? Well, okay, so a standard deviation is 3. So how many 3s are between 20 and 26? We can do this, right? You're probably already going 2 in your brain and you've got this, but think about what your brain's got to do to process that. You are saying, okay, let's take the 26, subtract the 20, and find out what the difference is between these two, which is 6. And then if we divide it by our standard deviation of 3, we're saying how many 3s fit in this distance. So 26 minus 20 is 6, divided by 3 is 2. That means that the number 26 is 2 standard deviations away from 20. It's 2 standard deviations away from the mean. What this allows us to do in our current day and age is have intelligent discussions about values in regard to their data sets without having to think about anybody's units. It doesn't matter how big or small the mean is. By knowing how many standard deviations something is away from the mean, we can decide the probability, likelihood of it happening. We can decide if it's normal or abnormal. Previous conversations have included 2.5 standard deviations is our realm for outliers, or at least it's one of the ways for telling outliers. So if you are within 2 standard deviations, it is normal. So even knowing nothing else about the set, we are less than 2.5 standard deviations away from the mean. So 26 would be a common value, a normal value, not in any way strange or abnormal in comparison to the rest of the data set. So let's see if we can actually put this into a formula. Dun, 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 dun. Ladies and gentlemen, what we've just calculated is called a z-score. So I can set that equal to z if I would like. A z-score, which can be calculated by doing what we just did. Take the original data value, the x, the 26, subtract the mean, 20, so figuring out what's the distance between these two numbers, between the x value and between its mean, and then divide, figure out how many standard deviations fit in that. That tells us how many standard deviations we are away from the mean. Ladies and gents, I cannot tell you how important this is, so take this, write this, put stars, celebrate, whatever you like, tape glitter to it, something like that. But this is a concept that's going to keep coming back a lot. All right, so we can discuss the value in relationship to its mean by how many standard deviations it is away from the mean. Not a difficult formula, but a really important one. All right, let's do a slight twist on this, shall we? Because that makes me happy. We just took a raw score, and converted it into a z-score. what if I want to go the other way around? What if I have a z-score and I'd like to convert it to a raw score? Well, all right, so let's just think about this, shall we? We've got all we need to think about this. Move these out of the way. There we go, there we go. All right, so let's say, just for the fun of it, that in response to your performance on your last test, your teacher hands you a z-score of 1.2. Huh. What does that mean? Great. 1.2. Does that mean I passed? Did I fail? Is that a 75%? What is a z-score of 1.2? This tells you where you are in relationship to the mean. Now, do think about this for a second. We do the x minus the mean. So this gave us a positive 2, which is positive because 26 was bigger than 20. So we were above the mean, and we had a positive z-score. So positive z-scores are going to have to mean something that is above the mean, which means if I had a value below the mean, let's say this was 19 just for a moment, all right, 19 minus 20 would give us a negative value here. So numbers that are below the mean are negative, numbers that are above the mean are positive. So right now, if I've got a 1.2 z-score on my last test, I'm going to start celebrating a little bit because it is a positive number, which means I am above the mean. I am above average in my class. Woohoo, yay me. All right, so positive numbers with the subtraction, in that order specifically, x minus mu, positive numbers give us values that are above the mean, negative numbers give us values that are below the mean. So, yay me, I am above average. I deserve a cookie. Okay, but I'd like to know something more. So, if I ponder this equation right here, saying, all right, I know my z-score, I know the 1.2. If I'd like to know my raw score, I would like to know my grade, I might have to ask my teacher a couple of things. Like, hey teacher, what was the mean of our test? And if your teacher's nice, your teacher will say, well, there was a mean of, let's just go with 85, shall we? There was a mean of 85. And I would also then need to know what my standard deviation is. So standard deviation, teacher says, was 2.3. So as a result of taking this last test, the class average was 85, and it has a standard deviation of 2. Did I say? Shoot. I meant to write 2.4 because I wanted to write 2.4. There we go. 2.4. Okay. And I have a score of 1.2 as a z-score. So if I think about this, I know I have a score of 1.2. I do not know my raw score. Minus 85. I know it's going to be bigger than 85, so I'm excited about that then too. Not only am I above average, but I'm above 85, so woohoo. And throwing a 2. Why do I keep writing the wrong number in the wrong place? You guys should be yelling at me right about now. Goodness gracious, that says 1.2. This should also say 1.2. I know that my z-score is 1.2. 85 is the mean, 2.4 is our standard deviation. Great, I can find my score. I just need to do 1.2 times 2.4, 1.2 times 2.4, which I'm doing in my calculator, which is going to be 2.88 equals x minus 85. So I should add 85 to that. Okay, so that's going to be 87.88 equals x. What does this mean? If I probably round that, that means that I got an 88 as a score on my test, which is my raw score. I'm going to celebrate that too because I'm happy about that. There we go, 88. So my raw score. Working backwards, working with this exact same formula. I will tell you this, although it makes me mildly cranky to tell you this, that some books have an actual different formula to take a z-score and turn it into a raw score. Okay, well let's think where this different formula might have come from. All right, so they're looking for, I'd like to know my raw score. What can I do? Well, what did we do? All right, the first thing we did is we did 2.4 times 1.2. So we did, z times sigma. We did z times sigma. So that was our z-score times our standard deviation. And then we added the 85, and the 85 was the mean, so we added the mean to that. And that gave us our raw score. Is this really a different formula? Rawr. No, it's not. It's the exact same formula. So why we need to present it this way, I don't know. To me, this is the only formula that you need. If you've got this one, whatever. Okay? This is the same thing. We're just rearranging it. Same exact stuff. Okie dokie. All right, so this, by the way, if you're in one of my classes, this is a foretaste of what is to come. because I really, really will give you a z-score on your next test, and you'll have to figure out what that means. So, ha ha ha. Be ready. Math in action. There we go. Bye.